Our final t-test is the related samples t-test. And the related samples t-test is what you're going to use when you have two sets of scores that came from the same sample. That means it's either the same person at two time points, or it might be two people who were paired, like a husband and a wife in research that's looking at couple satisfaction. This test also has quite a few names. A couple of them might be paired samples t-test or repeated measures t-test. The book calls it a couple other things also. Just keep in mind that they all mean the same thing. So here are two examples that might use the repeated samples t-test. Do rats move through a maze more quickly on the second attempt than the first attempt? This would be a related samples t-test because each rat will have two data points, a time 1 and a time 2, and that's what's being compared. Second one, do firstborn and lastborn children rate their parents' fairness and discipline the same? This isn't the same person at two time points, but the firstborn and the lastborn within a family are related. They come from the same structure of a family, so their data would be compiled together and require the related samples t-test. One perk of the related sample t-test is it has some advantages over the independent samples t-test. And the first is that it decreases the variability. When you have the same participants or participants from the same dynamic, like a family or a relationship couple in the sample, it decreases how much variability exists between the two groups that you're comparing. When we ran the independent samples t-test, the two groups were completely 100% unrelated, and that increases in variability. And when you have a decrease in variability based on the way the formula for getting the t-statistic, you increase your chance of rejecting the null hypothesis. So if you're able to have a related samples t-test, you have a little bit better chance of rejecting the null hypothesis than if you're running an independent samples t-test. So we go through our same test steps here for writing a hypothesis test with the related samples t-test. We would create a null hypothesis and an alternative hypothesis. So going back to my rat example, my null hypothesis would be that the rat does not go faster at time 2 than he goes at time 1 in getting through the maze, and my alternative hypothesis would be that he does go faster at time 2 than in time 1 in getting through the maze. So then you could find the t-value by the formula, or in this class we'll be using the PSPP output. I do want to say something about data entry again, because last week we had talked about how you wanted to stack the data on top of one another. In this scenario with the related samples t-test, you actually want to put it next to each other like you maybe had wanted to last week. So going to our question of are firstborns different than lastborns, these are the data points, and here we would enter it like this, where there's a separate column for the firstborn and another column for the lastborn. They don't get stacked on top of each other this time. And of course, after we look at the t-test and see the value, the p-value, we'd make a decision about do we reject the null hypothesis or retain the null hypothesis. If p is less than 0.05, we reject. If p is greater than 0.05, we retain. And then you would write your results report.